An LED lamp. One I got a while back. It spins very well. It looks a bit like a steering wheel. But I bought this one a while back. So long ago I can't even remember. It must have been an eBay listing. And I thought it was quite interesting because it reminded me a lot of the OSRAM Circolux lamps. Some fluorescent lamps you used to get that had the outer sort of ring and the electronic ballast in the middle. So this one is Edison's screw. Let me grab the meter. Let's test this and see what sort of power it takes. I used to actually have some OSRAM Circolux lamps. They lasted a good length of time. They put out a lot of light. They were very good. I'm trying to remember where I first saw them. Okay. Ooh, it's warm white. I'll put it down the way. It's drawing about 100 milliamps, 13 watts, and rough power factor of 0.5, which is a rough power factor, but hey, that technically means that it's going to draw about 24 watts in real life if people use it with the meters that register apparent power instead of real power. That's going to happen at some point. The power company is going to do that. I keep saying that. It makes it sound like I'm some sort of conspiracy theorist, but there's no conspiracy involved there. They will do that because, yeah, they have the option and, well, the temptation will always be there. Smart meters, they are very smart. You can make them do lots of things. So this one, I noticed already that you can pull the cap off like this, but this bit here is actually screwed on. Oh, that's rattly. That'll explain what was rattling inside. I'll pop that on again then. No, I won't. I'll just leave it off. So the original Circolux lamps, I remember seeing them in a venue. The Arches in Glasgow, which was under Central Station. It was the big stone arches. I used to attend a nightclub event there called BURLY, which latterly got raided by the police and shut down. It was very good. I enjoyed it. Lots of thumping dance music and, yeah, it was a good act. It was a good event. Ooh. Oh, it's using a standard. Oh, is this all going to come off? This is not coming off. Is there something else I don't know here? I'm seeing what could be screws, but the front plastic must come off now. Or is there something I just don't know? Am I going to have to pry something? Oh, I see what it is. There's clips. Well, that's pressed in quite firmly. Right, let's try getting it off. Which is what actually happened at Burley, come to think of it. Which is why it got shut down by the police. It was a very odd nightclub event. This ain't happening. Why is this not coming out? The DJ at Burley was Hi-Fi Sean, notable for a recent track he had in the charts called Testify with Crystal Waters. And when the police raided, they did arrest one person, who it turned out was a lawyer. Not sure what happened there. The Arches eventually, I think it might be open again now, but it got shut down for a long period of time because there were issues with, they weren't controlling, well, how can you control a nightclub? People were taking drugs in. That isn't why Burley got shut down, it was for a completely different reason. I'm not having much luck here. I'm going to pause momentarily until I've got this off. And we're in, and it appears to be parallel circuits of 4 LEDs. This is a group of 4 and then another group of 4 all wired in series. So I would estimate there's about 20 sets here. And again, in the middle, you've got 16 LEDs with 4 groups of 4 wired in series. And then the driver is a current regulated typical one that's feeding one end is feeding to the inner circuit, then there's a loop into the outer. So it's basically going round this circuit, coming back, going through this circuit, and then going back to the driver. So let's power this up. This is where it gets a bit dazzly. Let's bring a meter in and set it to volts. DC volts, and I shall measure the voltage across this. I'm going to have to go between the pink and one of the whites to get the voltage here, so I'm just going to plug this in. Let's bring in the lamp holder and twist it on. It's notable that when Burley was raided with police, the type of event was such that people thought it was an act and just all stood and watched. Oh well, these things happen. It was a worthy experience. I definitely enjoyed those nights. It was very, very loud nightclub. Good drinks, good fun. Right, okay, what am I getting? Let's see if I can not short something out dramatically here. I should have put dark glasses on for this. What am I getting? I'm getting a low voltage there, so that's the one to the inner circuit. So if I short over to this one, this is giving me, rather predictably, about 60 volts. That's 3 volts per parallel circuit. Now, theoretically, I can get the current, but it does mean bridging one circuit of these LEDs out. Hopefully it won't pop the LEDs in the process. So I'm going to put this to the 300 milliamp range. I'm going to turn it to DC amps. And I'm going to bridge a circuit. Not sure the polarity. Bridging now. 200 milliamps. So that's 200 milliamps, about 60 volts. Okay. Let's take a look at the power supply now. So I'll just carefully grip this and unscrew the cover. There we go. Let us explore this little power supply. I'm sure it will be discharged by now. Is it warm? I may actually take a picture of that with a thermal imaging camera once I've got this tape off it and see which component's getting the hottest. Keep in mind that they will get quite hot inside the fixture, hotter than they would be out here. So let's see what we've got. I'll gingerly pull this cover off. I'm confident. I'm going to poke that big capacitor with my finger. It's discharged. Russian roulette with capacitors, it's good. So what we've got a little switching power supply, a chip here, a little switching chip. The incoming supply looks as though it may actually, I'm not sure about this, I'm going to have to check this out. This may actually be a buck regulator as opposed to isolated switching supply, so it may be better treating this as if it's live. I shall check that, and I shall also power this up and take a thermal image, and we'll take a look and see what sort of temperature it gets up to. Well, that's reassuring. It's a BP9833A, which is a bright power chip. BPS, confidential, spread all over the internet. So this does mean that you've got the bridge rectifier feeding the LEDs directly, which means that ultimately they are referenced to the mains. And if I've got the meter set, now I've changed the leads back. I should mention that. Always change the lead back from the current to your standard voltage and resistance settings to avoid nasty accidents. That is a dead short circuit between common and the current mode. And particularly important with fluke meters because the fuse in here probably costs more than an entire meter. That's the peril of industrial meters. I wonder how many industrial meters are floating about with inappropriate fuses in them. So measuring from the input to the output, there is one diode junction. It's going through the bridge rectifier, so if you touched the output of this while you were referenced to ground, you would get a shock. It's not isolated. That's not a great deal. It's all fully enclosed. Unless, of course, you managed to pop that cover off, which didn't take much effort, to be honest. Quite a smart looking lamp, though, so far. I took a thermal image of the unit while it was running. The only component getting warm, and it's not hot, it's only about 55 degrees, was this the chip itself. And notably, with I used Christoph's lenses that he sent for the thermal imaging camera to get a good close-up here, and you can actually see the pattern of the thermal output in the chip. So it's all concentrated down this corner. So for reference, I put a dot on pin 1, and the hot bit is between the drain and the current sense, which you'd kind of expect, but it does suggest that most of the MOSFET in here is actually down at this area of the chip. Interesting that you can actually effectively see it through it thermally like that. The capacitors, let's see, 10 microfarad 400 volts is a good value of capacitor. On the output, that'll be this capacitor here. We have a value of, I have to fold this up to see that. Can I see it? Yes, I can. 400 volt again, 2.2 microfarad. That's fine because it is a fairly high frequency switching there. It's a textbook example of the actual design. It's just exactly what you'd expect. So it's not a bad lamp. I can't tell you exactly where I got this lamp from. That's not very helpful when I go, oh yeah, it's quite a good lamp, and then don't actually say the listing I got it from. But it's a very common style. So if you come across the ones that look like the little steering wheel of the Circolux lamps, that's probably it. So yeah, it's quite a neat one. I quite like that one. I'm not finished this yet. I'm going to do another experiment. I want to see how the power factor changes between using the switching power supply, which was about a 0.5 power factor, and a capacitive dropper, because this only represents about 60 volts. Now, this little power supply here is designed for controlling strings of LEDs, and inside is, I'm going to check it anyway, because it's always good to check these ones. Some of them came with the wrong label on them. Some of them were set for 110 volts. Yeah, this one looks at a 240 volt one. What's the capacitor rated? So this is a capacitive dropper designed for running long strings LEDs. Oh, 250 volts AC, the capacitor says. It's 680 nano, so it'll probably run those LEDs a fair current, but not huge current. It's a capacitive dropper with capacitor in series, the bridge rectifier and the capacitor, and then an output limiting resistor, just to take spikes away from when LEDs are put in or out. And this looks okay, so I'm going to use this, noting that the colour code of the wires is very weird. I also want to mention that I just looked up BURLY on the internet, and OMG, that is not the BURLY I remember. The newspaper articles about the police raid make it look like it was a cesspit of sex. It was not. It was a nightclub venue with dancing and loud music and beer and cider for... Yeah, it's very strange. I'm not sure. I get the horrible feeling the police may be fabricating evidence up there. It's certainly not how I remember. I don't remember seeing any of that. It's worth looking it up, just to see the shock value of how they describe it. It looks like a torrid event. Things worth a note here. You'd expect, I mean, the colours, you get black, white and two reds, and you think, well, what's going to be what for AC in and DC out? Well, the AC in is the reds, the DC out is the black and white, and you think, oh, black will be negative, but black is positive, white is negative, and the reds are AC. Wouldn't it be nice if they'd use white, two whites as the AC, red is positive and black is negative? That would have made things a little bit easier. So there are mixed articles online about BURLY. There are more factual articles which paint a nicer picture, and then there are the ones that, the sensationalistic newspaper ones that are just going for gold and getting the outrage set up. Good club night though. I enjoyed it when it was there. Kind of miss it. I don't think I've been to a club since. Another DJ was DJ Mishka. Big Will. Played a different style of music. Right, I'm going to tin these wires. I wonder what current this will pass when I do this. It'll be interesting to see what the current is through the LEDs, and that may be reflected in the power supply, the hoppy meter, should I say. So white is, no, black is positive, right? Yeah, see, it's that easy to make mistakes. I'll just have live wires dangling about. Oh, I just touched the solder iron to myself. Okay. Burny. And at least this is white to white, which looks kind of sensible. Even if it is the negative wire. Okay, that looks about it. So to connect this, I can shove this down the front of the hoppy meter. Yeah, there's a good chance that the Glasgow Council was behind the closing of BURLY, because they had strong family Catholic values. Like choir boys apparently, and kissing the Pope's ring. So yeah, I think someone had it into the arches. I don't know if they were wanting to maybe take the premises over, but they clamped down them. You know, they were quite destructive. The arches was also notable for hosting Alien Wars, which was an early walkthrough in the UK, sort of American horror style walkthrough. But it was based on the Alien. It was I think it was properly franchised from the Alien films, and they had characters. It was all done. It was done by geeks who were right into the sort of Alien stuff. the Geiger stuff. Some of the material they had was amazing. It was original props and stuff off the Alien sets. And yeah, it was so scary that people would run out and vomit in the street. So yeah, the Arches is just quite an interesting place. It was also an arts venue and used the club revenue to fund the arts, which was quite good. Right, okay, is this going to go bang? Let's plug it in and see what happens. That just blew all the LEDs, did it? I think that just did. That was not what I wanted. Was that Duff? That's a bit disappointing. Right, let's investigate what has just happened. Let's see if there's any obvious dead LEDs here. Why did it just do that? I'm going to get this cover off. I'm slightly disappointed what's just happened. I'm going to blame Glasgow Council. Right. Okay, I'm just going to oh, you know what? There's a broken connection in the capacitor. Is that why it did that? Let's try soldering that. One more. Actually, no, I won't pause. I'll just do it right now. Has that blown all those LEDs? I hope it's not blown all the LEDs. I think it's probably just been because that capacitor was not making a great connection. Right, tell you what, let's flow that across and see if we can fix this. So we'll fix it by using the scrub and blob technique. And that capacitor is probably still charged, and it's quite a beefy one, so maybe I'll just short it with a pair of scissors first. Oh, it was charged. Oh, spicy! So let's scrub that. I hope it's not I hope this capacitor isn't duffing, it's just blowing all the LEDs. I don't think so. Unfortunately, the way LEDs fail when you pump the mains through them just directly is they tend to do so in a very clean and precise manner. They just basically, they blow like little fuses inside and they make a little pop just like that one did, and a little flash of light, and that's it. The game is over. Okay, let's flood this on here. And there. Pretty sure that the Arches was opening again recently. They were hosting a sort of social... I don't know if they were trying to get rid of the place, or not get rid of the place. I don't know if they were trying to sell it to developers, because it's quite an odd venue. It is literally underground caverns under Glasgow Central Station. I don't know why they clamped down it so much. But I think it is being resurrected, and I hope it's not just... I would guess because it is all vintage, Victorian-y type stonework, which really added to the ambience of that club night. I wonder if it tends to suffer from mould and stuff like that a lot, because it just strikes it that it would be quite damp under there, because it is underneath a train station and sort of an outer exposed area with trains dripping with water when they come in. Right, let's plug this in again and see what happens. It's lit. All right, okay, that's better. I've not blown the ass out of it. Keep in mind this is live. Right, let's put it down like that. A bit flickery, that's okay. The power factor is indeed actually down its half, and that kind of tallies up. If you consider, it's showing 46 milliamps. If you consider 2.9 watts, that's really low, but it still looks quite bright actually. The power factor has dropped to about quarter here, 0.25. Now, proper unity power factor is a perfect resistive load like a traditional tungsten lamp. That would be one. This relates to the wave relationship between the current and the voltage, and these things deliberately shift that to basically limit the current through the LEDs without dissipating a lot of heat. So this will actually remain stone cold, except when it's making popping noises and sparking and things like that. But that kind of tallies up, because if you consider it, it's a 240 volt supply, 60 volt LEDs, it kind of, it does that. Is that why it's relating to exactly a quarter, which is, 0.25 is a quarter of 240. Is that a lucky coincidence? Not sure. Let's measure the current. The voltage across the LEDs will still be in the region of about 60 volts. I'm just going to prod carefully here because that is all spicy and live down there. Let's nudge everything up, including, yeah, sorry about the flicker, it's just that slight shimmer. That could have been dealt with the capacitors a bit better in that unit, but those little power supplies are extremely hackable. They're eBay specials. Right, so let's put this to the current setting. Whack it round there, and it's showing 46 milliamps here, but what's it going to be by the time it's been smoothed? So I'm going to short out an LED here. It's about 37 milliamps. Those LEDs are going to run so cool with that. That's not a bad light actually. It's not as much light obviously as it was before, but it's an interesting thing. Change the leads back to avoid any expensive fuse blowing. So yeah, interesting light, interesting nightclub. And the inspiration for originally buying those Circolux lamps, I should try and get one of those Circolux lamps. I have some still in storage in Glasgow. And I used them for so long that they ended up actually, some of them burnt out. And they would, like fluorescent fittings, well, like LEDs do. They used to reduce intensity over time, just as the phosphor degraded. And it was interesting because if you've seen inside the compact fluorescent lamps that they've got the inductor, they've got a little toroid, the feedback coil. That got so hot that it actually made the circuit board brown round it. It was quite unusual to see that component getting hot. But yes, interesting. This is quite a smart little lamp. I shall actually put it together again and use it probably. And I'll put the original power supply back in because it seems more efficient than using a capacitive dropper.